Algebra 1, Chapter 1, Section 7. Functions. A function is a special kind of relationship, and it's important to look at the input and the output because for every input there's exactly one output. And so far, the examples we looked at in relationships, those were all basically functions except, well, the ones in the videos were functions. I can't remember about the homework. But with the functions, let me write down a little relationship here real quick. Remember, this is domain and range. 1, 2, and 3, 4, 5, and 6. Relationship is just going from one to the other. And this one here is a function. Every input, the left-hand side, has exactly one output. That doesn't always happen. Sometimes weird things happen. And let's do 1, 2, and 3 again for the inputs. But this time we're just going to do 4 and 5. In this problem, let's say you have a relationship where 1 goes to 4, 2 goes to 3, 3 goes to 5. You're okay right here. This is perfectly fine. What the problem is, and I'll draw it in green here, if 1 goes to 4 and 1 also goes to 5, that's what makes this not a function. Not a function. And so what you're looking at here, the problem is 1 and 4 are paired together and 1 and 5 are paired together. That's the problem. It's okay if 1 goes to 4, 2 goes to 5, and 3 also goes to 5. That's still a function. That's okay. It doesn't have to be a unique output. It just can only go to one place. But that green arrow of 1 going to 5 changed it to where it makes it not a function anymore. What that can look like in your graph here, 1, 4, 2, 5, 3 goes to 6. That's my graph there. When we're looking at the not a function, 1 goes to 4, 2 goes to 5, 3 goes to 5, but then 1 also goes to 5. So let me do it in green here so you can see that it's the one problem position again there. Because they're stacked right on top of each other, one right on top of the other, that is the problem. We actually have a test for this called the vertical line test, where you can see later on where because it stacks up vertically between these two, I'll kind of draw it in pink here. Because they're vertically on the same line, that's where the problem comes in. All right, but that's what a function is. Every input has exactly one output. So we're going to try to identify if these are functions, and they're giving the relationships to us in two different ways. Here I have a domain and a range. Domain -2 goes to -3, 0 goes to 6, 3 goes to 6, and 4 goes to 9. Now what you're trying to look for here is let me not do this in pink here. Any repeats in domain. If you have a repeat in the domain, it better go to the same exact spot in the in the range. So like if I have a -2 down here, it better go to -3 again. All right, because it's the only output -2 is allowed to go to is -3. The other thing is multiple arrows out of one domain value. If all of a sudden 0 also goes down to 9 there, that messes the whole thing up. No good. Fortunately, we don't have any of that. Nope. Oops. Nope. And Nope. So that works just fine. So I would say this is a function. The explain part of it here, I just use the definition. Every input has exactly one output. Now let's look at B. We're going to ask the same questions again. Are there any repeats in the domain? Ooh, I see 1 there 2 times. So now I have to double check. Do they go to the same spot? 1 goes to 4 and 1 goes to -4. So here I would say, yes, there is a repeat in the domain, and no, they don't go to the same spot. So that tells me it's not a function. I only have to find one example of it. I don't even care what the other numbers are doing. I found that one problem, that's enough. So I'm going to say this is not a function because, and this is the explain part, before when I explained it was a function, I just used the definition. To explain it's not a function, I'm going to say how it doesn't fit the definition. So because the input 1 goes to 4 and -4. And that's all I need to explain it. Tell me the exact one time that it messes up. All right.